My lords, that's me, ladies and gentlemen, Professor Richard Lindzen needs no introduction, but that doesn't mean he's not going to get one. The Professor of Planetary and Atmospheric Sciences at the Massachusetts Institute of Technology has steadfastly refused to engage in political debate on the subject of global warming. Instead, as you will find from his presentation to you today, he adheres rigorously, vigorously, as every scientist should, to the science. And we are very, very lucky indeed to get him. He is in enormous demand around the world. And, for instance, he has appeared before the United States Congress. He has participated, much to his displeasure, in the meetings of the Intergovernmental Panel on Climate Change, and therefore is well aware of the political machinations which predominate over science in that not very august body. But above all, he has devoted a lifetime to the study of the peculiar behavior of our atmosphere. And of all the people I've met on both sides of this debate, none but he has displayed the exceptional, intuitive, affectionate, profound knowledge of how the atmosphere behaves and how it is likely to behave as we influence it than Professor Richard Lindzen, whom, without further ado, I invite you all to welcome in the warmest possible fashion.
Thank you, Chris, for those kind words. I hope all of you have had coffee for lunch or something. One of the things about science, there are people who can make it exciting. I'm afraid I'm probably not one of them, but still, it's good to be here in these lovely surroundings. And I do want to thank Faye and the campaign to repeal the Climate Change Act for the opportunity to present my views. Where's the mic? Here. This work better?
A taller one, look.
Ah, even better. Yeah. Maybe this one. Well, who knows? This is better. Yeah. In any event, in clarifying, in trying to go over this debate, one of the problems, and I think Phil referred to it, you're asked, do you or don't you believe? And you're not asked, what is the question? What is it you believe or don't believe? What is it you're questioning? And I'd like to clarify that, because the debate is not over whether climate is changing. It always changes. It's not about whether carbon dioxide has been increasing. The measurements are pretty good on that, although they're less clear on why. It's not about whether adding CO2, carbon dioxide, to the atmosphere will give you some warming. It most assuredly will. So what is the question that is really before us? And it is the question, as always in science, and Lord Kelvin stressed this, without numbers, science is not a very meaningful thing. The question is, how much? There's a second question. We're talking, as we'll see, about tenths of a degree. This isn't much. Your own body temperature fluctuates that much. The notion that the world rides on that seems a little bit peculiar. But even more peculiar is the fact that, since that, for most people, does not sound like much, the advocates of this issue have to tie it to catastrophes. Sea level rises of 20 meters, hurricanes hitting you day and night, all sorts of things. It goes to the extent, and there's one semi-political issue, the funding for this subject has increased so much over the years that there are nowhere near enough people in climate science to use it. And so what's happened instead is you've created a whole new area, climate impacts. So if you're studying cockroaches and you need funding, you'll title your proposal Cockroaches and Global Warming. It's gotten so bad that, for instance, obesity in the U.S. is being attributed to global warming. I'm sure that's not the cause of my obesity. But in any rate, the connection to catastrophes is itself a wide open question, and one where the arguments are not only weak, they're frequently totally dishonest. If we have time, I may go into that a little bit. I'm going to start with material that I think is pretty accessible. And if time permits, I'll go into material that's harder to deal with. And you shouldn't worry. Students have trouble with this topic too, but it doesn't mean it's unimportant. One problem with science when it enters the public domain is the issue of oversimplification. And this issue has been affected by that greatly. I mean, from the beginning, there was an attempt to explain to people what the greenhouse effect was, and Gore and company said it's a blanket. And then you had a whole bunch of people who were saying, well, CO2 can't act like a blanket. And they were probably right, but that isn't how the greenhouse effect works. And, you know, it's where the simplification gets people thoroughly confused. The whole discourse falls apart. In any event, I'm going to start with two statements that, in fact, the IPCC is completely compatible with. And this is often not understood. It's easy to attack the IPCC, but what is often forgotten is the spin that is put on statements that are actually not that bad. If everyone were actually to read the 800-page report, they would soon see that the presentation by the advocates is not accurate. And what has become commonplace in this is for somebody to say, global warming is going to destroy the habitat, it's going to get rid of species, it's going to do this, that. And they'll cite as their authority the IPCC. And you can't find it in there. It's become a symbolic source of authority. Anyway, let's get to these two statements. The first one is, a doubling of carbon dioxide by itself contributes only about 1 degree centigrade to greenhouse warming. Now, the point is, all current climate models used by the IPCC project more warming. And the reason they project more warming is in the models, other greenhouse substances, most notably water vapor and clouds, act to amplify whatever CO2 does by factors of 2 to 5. Without these positive feedbacks, there certainly would be no basis for alarm. The other thing is, even the warming record, and we'll come back to that, where people are arguing, has it cooled 1/10 of a degree, has it warmed 1/10 of a degree, as though you could measure 1/10 of a degree. But even this record, if you were to say that for the past century, all the warming trend was anthropogenic in origin due to the greenhouse effect, you would deduce a sensitivity that is on the order of less than a degree, which would imply negative feedbacks. The question some of you might wonder about is, if this is the case, how did the models simulate the past? Because one of the common claims is they can tell you what happened in the past. It's not a very good test. It's like saying I can do well on an exam if you give me the answer in advance. But the way they make them consistent is to take two fudge factors. One is called aerosols, and the other is called solar. Trouble is, we don't know any of them, but by choosing them judiciously to cancel the excess warming, you can simulate the past. The giveaway that these are what financial planners would call plug variables is each model uses a different value. They're not a known thing. Anyway, that's all I would say, just given this situation. And I would say there can't be an argument about what I've just said. It's hard to understand what anyone means when they speak of global warming being settled science. I think we'll get a hint at what they mean in a few minutes, but it clearly cannot be that the alarming aspects of global warming are settled science. Okay, so let's think about this a minute. Carbon dioxide has been increasing. There is a greenhouse effect. There has been a doubling of equivalent CO2 over the past 150 years. That is to say, CO2 hasn't doubled, but you've had methane increase, you've had nitrous oxide increase. When you add them all up with the freons, you get the same greenhouse effect as you would from doubling CO2. So it's not as though we're far away from that. We're there. There has probably been around 0.8 of a degree, 0.7 of a degree warming in the past 150 years. And increasing greenhouse gas alone should cause some warming, about 1 degree centigrade for a doubling. Nothing on the left that you see there is controversial among serious climate scientists. Nothing on the left implies alarm. Indeed, the actual warming is consistent with less than the simple effect of CO2. And the problem in the public discourse, in part, is that you will have people who are denying things on the left. And that has given a pass to the people promoting alarm. They can devote themselves to defending the left side of this, even though it doesn't imply alarm, and their excuse will be there are people who are questioning these things. And that is a real diversion of the actual debate. And in my opinion, I know Chris agrees with this, if the warmistas, as they were called, could pay the people who deny the left, they couldn't do better in terms of public argumentation. Okay. The usual rationale for the positive feedback is models. And we'll come back to that a little. Very frequently you'll see, and the IPCC rather endorses this, the notion that models are our only tool when confronted by complexity. Even if you believe that, it would depend on the models being objective and not arbitrarily adjusted. And unfortunately, these are unwarranted assumptions. The models, however, are not our only tool. They're sometimes useful. I don't reject them. One of the things models are useful for is you can study with them why the models get what they get. Forget about nature. And that can lead you to the more focused question about how do the mechanisms that cause the models to behave the way they do, how do they function in nature? And we'll come to that later. The results inevitably show that the models are exaggerating warming. Okay. Quite apart from science, it seems to me there are reasons why people should be suspicious of global warming alarm. And my feeling is, and it's always astonishing to me, the public at large gets this. The people who don't get it are the educated elite, the academics, and so on. And I find this quite remarkable. So, for instance, if somebody is talking about science and they're talking about incontrovertibility, I think the public at large knows they're not talking about science. Arguing from authority in lieu of scientific reasoning and data, or even elementary logic. You see this all the time, ad hominem attacks, attacks on funding, allegations even when false, but not a discussion of the science. The use of the term itself, global warming, without definition or quantification. I'm always surprised. I mean, I do deal with reporters and people and so on. I said, what do you mean by global warming? And, well, the globe is warming. How much? How do you measure it? What do you do? Absolutely clueless. There's another thing that lawyers here will be familiar with. I'll come back to it. The prosecutor's fallacy, where you identify complex phenomena with multiple causes, with global warming, and even use them as proof of global warming. So, you know, for instance, storms in mid-latitudes have many causes. And in fact, one of the things that would reduce the storminess is global warming. And yet somehow, if you have a stormy year, you're told that's proof of global warming. This is, even by the normal courtroom standards, is a bit bizarre. And finally, there's, you know, the most recent issue where instead of global warming, it's climate change, and the very existence of climate change is taken to be identical with anthropogenic warming. This is something that you don't have to be a scientist to realize these things are dicey. You know, virtually by definition, nothing in science is incontrovertible. And that's especially true in a primitive and complex field like climate. As has been already pointed out, incontrovertibility belongs to religion where it is referred to as dogma. As noted, the value of authority is of dubious value in a field like this. You have to dig into the science yourself if you want to deal with this issue. And sometimes people take the view that this is too hard. And, you know, at some level, that's correct, although there was a wonderful political scientist, Aaron Wildavsky, who wrote a book about 10 years ago, But Is It True? And it dealt with the issue, how do laymen, how do non-scientists deal with important political decisions that have a strong scientific component, as is typical of almost all environmental issues. And his conclusion was, indeed, they had to go to the actual literature and maybe discuss it, but there was no way to use condensations and summaries prepared for them as laymen. At any rate, as I say, this isn't as hard as you might think. This is an example from a couple of years ago. The letter has been sort of publicized again. There was a letter in Science magazine, sort of the American version of Nature, and it was signed by 250 members of the National Academy of Science. This is an interesting use of authority because most of the signers had no background whatever in climate science, and quite a few of them were active environmental campaigners. Paul Ehrlich of the Population Bomb, the late Steve Schneider, George Woodwell, Don Kennedy, John Schellenhuber, who was Merkel's advisor on this for years. But there were among these some people who were legitimately doing science. So one of the easiest checks you can do is check their scientific papers against the statement that was in Science magazine. And for one of them, it was pretty easy. Here are some of the assertions in the letter to Science. Natural causes always play a role in changing Earth's climate, but are now being overwhelmed by human-induced changes. And another point was, warming the planet will cause many other climatic patterns to change at speeds unprecedented in modern times, including increasing rates of sea level rise and alterations in the hydrological cycle. Now, one of the signers of this was a colleague of mine, Carl Wunsch, who's an oceanographer, and he's been studying sea level rise for some years, and he's been very prominent in this satellite TOPEX that accurately measures levels. And he wrote a paper in 2007, and he repeated the same material actually a few weeks ago. And his point in the paper, to quote him, it remains possible that the database is insufficient to compute mean sea level trends with the accuracy necessary to discuss the impact of global warming, as disappointing as this conclusion may be. So the point is, this is not a hard, although the language is convoluted, as it always is in this subject, it's not a hard sentence to understand. In brief, if you actually go to the scientific literature, you'll see that, as you will in looking at the text of the IPCC, that the authoritative assertions are no more credible than the pathetic picture of the polar bear in the front of the article. I mean, if you can see him here, he's wandering on this poor ice float. It's a photoshopped picture. In any event, what have I got here? Okay, now let's get to this issue of what global warming is. It's a pretty obscure statistical quantity. It's the globally average temperature anomaly. What this means is you take each of the stations, you take the time series of temperature, you average for a 30-year period, I forget which one, most of them I think use something like 1950 to 80, and then you simply record the deviations from that average at each station, and then you average those deviations over the globe. We'll come to how that works in a moment. But what it will do is take these huge fluctuations at each station, and most of them are totally uncorrelated with the global mean, extract the small difference of these, largely uncorrelated. It's a highly uncertain quantity, but it's probably on the order of 0.7, 0.8 degrees centigrade over the past 150 years. We'll see why you can't be certain of it. The quantity itself, if you look at any graph, is always going up and down. It's fluctuating at the level of 0.7, 0.5 degrees all the time. Has been doing it for the 150 years we've had the measurements. There have been periods of warming, cooling on virtually every time scale. 150 years is nothing special. There are phenomena that have 60-year periods, 100-year periods, and so on. And on these time scales, people will frequently say, I see a graph, I see something changing. Why is it changing? And it's very hard for people to accept you don't need any external cause. You don't have to force it to change at this level. You don't have to force it any more than a building, a skyscraper in the wind vacillates. Nobody had to push it back and forth. The presence of even a steady wind, it'll vibrate. What happens is the system is never in equilibrium at the surface. There are always ocean systems, current systems, taking heat away from the surface, bringing it to the surface. And so the surface is never in equilibrium with the sun. There's always storage of heat, release of heat, and so on. And you're talking about a few tenths of a degree, and the ocean circulation systems have very long time scales because of the high heat capacity and inertia. Okay, because we're talking about something very small, and the error bars are so large, it does make it easy to abuse this quantity. So here you have a picture of the temperature record from the Hadley Climate Research Unit database. Of global mean temperature anomaly since 1979. And, it's an interesting point of contention. It's been generally, anyone looking at this immediately sees nothing much has happened for 15 years. Phil Jones acknowledged that there's been no statistically significant warming in 15 years. However, there are uncertainties in this data, and small adjustments can result in negligible warming or cooling over this period. And what's quite remarkable in the polarized public discourse is as soon as somebody changes one thing a tenth of a degree and it shows insignificant warming, and somebody else looks at it and says there's insignificant cooling, each calls the other a liar. Fact is, there's no statistically significant change. Let's look at the issue of how you get this data, because that's kind of fascinating. And nobody has done this in 20 years. It was a guy, Stan Grotch, who did it at Lawrence Livermore Lab. Here you have all those points that go into the average. Each of these points is for a given year, the global mean, the mean temperature anomaly from each station. So you get this cluster of points. And if you look at the scale, the units here are 2-degree intervals. Okay, 2 degrees centigrade. And it's just a smear across 2 degrees. You now average this data and you get the thing on the right. And this has the same scale as the figure on the left. And normally, I would say, if you got this, you would say that the average looks like almost all the deviation on the left has been canceled out. You don't expect it'll just be flat zero, but this is pretty close. So how do you derive something arguable out of this? Well, very simple. You change your scale. Now the intervals are not 2 degrees, they're 2/10 of a degree. And this looks much more significant. I don't know, I haven't followed the Financial Times and so on, but in the Wall Street Journal or any other newspaper in America, you have the stock market reports for the day. If the Dow Jones went up 10 points, it fills the graph. If it went up 200 points or down, it fills the graph. As far as the graph goes, it looks the same for either of them. Now you have a significant change. You've done it by stretching, but here's something that will give you a little perspective on it. This is something, it's sort of visible here. It appears, this is a couple of years back, but the local newspaper in Boston, the Boston Globe, every day publishes a picture like this. So this one was April 30th, 2008, and you have these blue things here. That is the high and low for the day and a bar connecting them. You then have the gray, dark gray, and those are the normal highs and lows for the day, just average. And then you have the light gray for each day, and those are the record-breaking highs and lows for that day. they could come from any year. So for instance, for April 30th or 29th, the record high was 1974, and the record low is 1909. Okay. And you see the scale on these is pretty large. This is degrees Fahrenheit. So you have 60 degrees between, more than 60 degrees between the record high and low. But even in a given day, you have quite a lot. And then there's a red line here. What is this red line? The red line is a line whose thickness represents the range of global mean temperature anomaly over the past century. That's just to put it in perspective of your regular experience. Okay, just for the fun of it, a friend of mine prepared this diagram. If you look back at the temperature diagrams, there's warming sort of until 1940, then a bit of cooling. Then there's been warming since the late 70s. And the IPCC has stressed the most recent warming period as being clearly anthropogenic. Okay, so you have a natural period of warming, 1895 to 1946, and you have one which presumably is due to us, the last half century, 1957 to 2008. You tell me which is which. The time scales are identical, the temperature scales are identical. There's been no fudging with that.
That's very good.
Doesn't matter. Okay, some points to take away from the global mean temperature anomaly record. Excuse me, pushing the wrong button. Changes are small. They're on the order of several tenths of a degree. Changes are not causal, but rather the residue of regional changes. Changes on the order of several tenths of a degree are always present at virtually all time scales. And obsessing on the details of this record is more akin to a spectator sport or tea leaf reading than a serious contributor to scientific efforts. Say at least so far. I mean, if someday I should see the changes are 20 times what I've seen so far, that would be certainly remarkable. But nothing so far looks that way. The claim that the Earth has been warming and there is a greenhouse effect and that man's activities have contributed are trivially true and essentially meaningless in terms of alarm. We've already mentioned this. I'll repeat it because we see it coming up again. For instance, they're treated as the evidence for alarm. So for instance, a couple of years back, the late American physicist Hal Lewis, a rather distinguished figure, resigned from the American Physical Society, and it was over global warming. And the American Physical Society responded. On the matter of global climate change, APS notes that virtually all reputable scientists agree with the following observations. Carbon dioxide is increasing in the atmosphere due to human activity. Carbon dioxide is an excellent infrared absorber, and therefore its increasing presence in the atmosphere contributes to global warming. And the dwell time of carbon dioxide in the atmosphere is hundreds of years. On these matters, APS judges the science to be quite clear. The first two items are essentially what I refer to as the trivial agreement. The last item is not, and it's pretty misleading in its own right, but I won't spend time discussing it. There is on top of all this an increasing sense of corruption. So the APS also denies financial involvement, despite the fact that the chairman of the committee writing these reports is Bob Socolow, who is chairman of the Carbon Mitigation Initiative and on the advisory board of Deutsche Bank. heavily involved in this. Two separate but frequently conflating issues are essential for alarm: the magnitude of warming and the relation of warming of any magnitude to the projected catastrophe. I mentioned before the business of the prosecutor's fallacy. This basically, in its simple-minded sense, says the near certainty of the fact that if A shoots B, there will be evidence of gunpowder on A's hands, and confusing this with the assertion that if C has evidence of gunpowder on his hands, then C shot B. Everyone, I think, can see the fallacy in that line of argument. With global warming, the line of argument is even sillier, and I've given this before. Generally amounts to something like if A kicked up some dirt, leaving a dent in the ground into which a rock fell, and B tripped on this rock and bumped into C, who was carrying a carton of eggs, which fell and broke, and then if some of the broken eggs were found, it showed that A had kicked up some dirt. These days, we go even further. We decide that the best way to prevent broken eggs is to ban dirt kicking. Some current problems with the science. There's questionable data.